minutes, the plant completes a flat six engine. The plant makes more than 20 different versions of its flat six-cylinder engine, ranging from 255 to 535 horsepower. Each version of the flat six-cylinder engine has many of its own specific parts. The challenge is getting the right parts to the right place just in time for the engine's assembly. So Porsche developed an automated logistics system. Engine parts are loaded onto a cart. The cart is then picked up by Porsche's patented driverless transport system. Carts are programmed to take a specific route to the engine assembly area. The route takes them over a bridge and into a lift, where they go down one floor and deliver the parts to the engine assembly area just in time. The factory has a total of 21 carts. 9 of the carts are dedicated to removing completed engines from the engine assembly area. The carts take the finished engines back up to the logistics area. But how do the carts know where to go and which path to take?
Every 5 meters we have magnets embedded in the floor which are covered by concrete. And between one 5-meter distance and the next 5 meters, the cart is programmed to find its way. This, for example, is such a spot.
Each cart travels 20 kilometers every day at speeds of over 5 kilometers per hour. The people on the floor seem to know how to stay out of the cart's way, but just in case, there are safeguards.
As we can see, nothing happens even though it's carrying a heavy load, and these carts move at quite a high speed. But nothing can happen because we have a built-in safety system in there.
For every flat six-cylinder engine made, there are 3 parts deliveries to the assembly floor. The first parts delivery is pushed by hand. It contains both halves of the crankcase, the crankshaft and pistons. Early in the line, pistons are assembled. Then the first 3 pistons are carefully put into the crankcase. Then the crankshaft is placed into one of the crankcase halves. That first row of pistons is linked to the crankshaft. Then a robot installs the second half of the crankcase and bolts it on. Now the partially assembled engine travels to the main engine assembly line. Meeting that partially assembled engine, a special carrier called a cross-member. The cross-member allows technicians to maneuver the engine for easier assembly.
You can rotate the engine, you can lift and lower the engine, so that the workman always works in an optimal ergonomic position.
2 stations down, a technician puts the cross-member to work, flipping the engine on its side and installing the remaining 3 piston heads. The technician cranks the engine to check the piston linkages with the crankshaft, ensuring the operation is smooth. Next, a cylinder head is placed onto one side of the engine. The cylinder head contains valves that will let air into the cylinders and take exhaust out. Technicians put the cross member to work again, flipping the engine, so the other cylinder head can be installed. Every 2 minutes and 44 seconds, the engine reaches a new station. Some stations are manned by human beings, others are handled by robots.
Automatisierung macht an den Stellen Sinn.
Automation makes sense in those places where many things are repeated. If you screw 20 screws into an oil pan, it's not necessary that one employee screws in 20 screws. A robot can do that. That doesn't achieve any added value. But if you have complex assembly procedures, you need the employee.
About 2/3 of the way through the line, every engine goes through what's known as a cold test. Here, the engine is electrically cranked and turned. Its linkages and systems are checked by computer. After the test, the intake manifold is installed,